Hi, my name is Mitesh Mutha and I work for Concept Reply. We are the reply group expert pool for Internet of Things. We do all things IoT related basically. In this video, we are going to present a small demo project we developed to explore CrateDB. We have considered a simplified scenario that we have worked on in the past. In this scenario, we are creating a platform for fleet management. There is a fleet provider who manages all the different fleets. There are managers per fleet who manage a fleet of vehicles. The vehicles are connected to the backend and report various data points. For example, battery health related data, location data. Let us now look at different kinds of use cases in the context of databases that we focus on in this scenario for the demo. So we have different kinds of database usage that is needed in this scenario. We have relational data, data of vehicles, that stage data is like model name of the vehicle, engine type, etc. We might have many vehicles across fleet and there needs to be efficient search provided which can handle basically full text search over big volumes of data. There is also this typical IoT use case where connected devices report data points to the backend. For example, here the vehicles are reporting battery health related data metrics regularly. This is a type of time series data with high ingestion volume. We need to be able to aggregate and analyze this. The vehicles also report their location and we need to be able to identify if a vehicle is located within a specific boundary, for example, say a specific city. So this briefly covers the different kinds of data storage or uses that we want to do, and in this case, CrateDB is a great solution for this. So what is CrateDB? CrateDB is an open source database which handles multiple types of data. We think it's nice to be able to analyze different kinds of data within a single system, and you can use native SQL for simple queries. It is PostgreSQL compatible, and that helps in onboarding and integration. Let's explore this further. So this was all about the CrateDB. So let's see how in our demo project we have used the various aspects of CrateDB.
Okay. All right. So we are already running our HTTP server written in Golang connected to CrateDB. So yeah, you can see here that it's already running. So we here just to give you some context on the setup here. Basically, a user can make a request to the Golang microservice, which makes SQL queries to CrateDB, and we also have a K6 utility for some kind of load testing that we'll show you later on in this demo. So if you can see on the left, there are these endpoints, different sort of endpoints get put. So let's see, for example, the post measurements. So what we are doing is just running some SQL queries whenever we hit some endpoint. So yeah, let's now focus on the search use case. So for this, we created a n-gram analyzer. So CrateDB provides tokenizer, we called it 3 grams. So basically it looks at three letter length words, and we are creating this on the vehicle data, so we can use this to search. So we've already added some data into the database. This is the vehicle data that we've added. We have something called VIN, vehicle identification number, and we will search for like worded 3 letter length string within this VIN. Yeah, so if you see here, we have some data. We searched for 7DC, but if you look at the data results, we also see 7DC, but we also see 70C. The reason for this is because we wanted some fuzziness. People can make mistakes when they type in this query, so we added some fuzziness. So this is within the SQL command that query that we write, we have added in some fuzziness. So you can make a mistake of up to 1 letter, and it will still find the result for you. So this was about the search and how we used the CrateDB functionality here. Now let's look at the geodata. So what we did for geodata is basically a vehicle will report its location, and we have countries in our database. For example, Germany, Austria, these are all the geodata has been added to the database. Polygons, etc., whatever the coordinates of the fence of these countries. And yeah, so now basically when a vehicle sends the request, we will look at the vehicle location. When it sets the vehicle location, then we also try to match if it was present within a country, and that's what we're going to do. So we're going to do a quick demo of this. So for example, when we do say a city close to Munich, or a place location close to Munich, yeah, so this location is close to Munich, and we have sent this data. The vehicle has sent this data, but in the backend you can see that once it was upserted, we can also see that the vehicle is in Germany. So the backend did the SQL query and identified that it's in Germany. Similarly, let's try one more with say Vienna, and you can see that the vehicle is in Austria. Yeah, so this was about the geodata handling of vehicles. Now let's move on to time series data. So we'll go back to the measurements that we're talking about. Basically, the vehicles send measurements of the battery health, which is called the state of charge. So it keeps sending this data to the backend, and we have created yeah, so this is the table on the right. This is the schema. This is partition by measurement partition. So basically this is time based. Every minute a new partition is created because there's a lot of data that is coming in. We also create four shards. So we will talk more when we show you the dashboard of how these four shards are in the backend in the CrateDB. So now let's just run our script. Yeah, so this is continuously sending data to the backend and creating, basically inserting new measurements. So if you look at the dashboard of case 6, all right, so yeah, if you can see here, the request rate is around 10 requests per second. Let's just kill our Golang server, and see how the request rate is changing. Yeah, so yes, we have killed our Golang server, and you can see that the request failed rate has shot up as soon as the server was down. So we bring back the server. Great. So now the server is back. Now, so this is continuously inserting data, and the request rate has fallen down back to 0. Now what we are going to do is look at the partitions and shards in the CrateDB dashboard. Yes, so this is the dashboard of CrateDB, and they provide a view into the partitions and this thing. So you can see that this is the list of partitions, and every minute there will be a partition that will be added to this. Yeah, so different number of records, and yeah, this is a view of the shards. So here you can see that this four rows correspond to 4 nodes, or basically 4 shards here, and we also have these partitions. The vertical columns are partitions. That is the more bright version is the primary partition, and the other one is the replica. And you can see that there's always a new, as new partitions are added, there's something that is a primary and a replica is created for it, and so on. Now what we're going to do is kill one node. So let's try killing a particular node. So we're going to kill this node, and this has gone. What happens is the replica now becomes the primary here. Basically, even though the node has failed, the CrateDB basically gracefully is managing this situation, and and trying to bring back the node again. You can see that there are no failed requests even now, even though our node is down, because it's being handled by the other nodes here. And we can kill one more, and basically the other node has taken over the case of being primary, in that case the other new node. So this is basically how CrateDB can gracefully take over and manage these things. And that was about the time series handling. We also do some aggregation analysis with it. We can see that so if you look at this code, we are doing some analysis and aggregation of the data because it's a time series data. And so all of this was done via SQL commands communicating with CrateDB. So this is, for example, the average state of charge, where basically we are aggregating over time intervals of 1 minute the average state of charge reported by a vehicle. So a vehicle ID has this kind of state of charge values, and this was all done by SQL aggregation on CrateDB. So this was all the different use cases that we can handle within one CrateDB system. That was the demo.
Okay, so yeah, that was the whole demo. We showed you the code, different kinds of handling that we did with CrateDB. And feel free to just scan this QR code. You will get to the source code of our demo project and you can see for yourself how it was implemented and what was done. Feel free to explore CrateDB. You can always reach out to us in case you have questions. We'll be happy to answer those questions. And feel free to reach out if you want to talk about something. Thanks. Bye.